Hopefully you did this problem. If you haven't, make sure you stop the video and try it on your own. So we're going to find the derivative of g at x. And that x is simply an arbitrary value for x. We know the derivative is the limit as h goes to 0 of the difference quotient. Notice again here, h is going to 0, g is just some arbitrary value. So we're going to plug in x plus h into my function g. So that looks like taking 3 times x plus h, quantity squared, minus 8. And then I'm going to plug in just x into g. And that looks like 3 times x squared minus 8. Once we have this limit, we're just going to do some algebra here. When you take x plus h and square it, you end up with an x squared plus 2xh plus h squared. Then we can distribute the 3. If I distribute the 3, I end up with 3x squared plus 6xh plus 3h squared minus 8 minus 3x squared minus 8. I could have also distributed this -1. In fact, I'm going to do that right now. Distribute the -1. We get a minus 3x squared and a plus 8 on the right-hand side there. When we combine like terms, what happens, let me just erase the whole thing. 6xh plus 3h squared remain on top because the 3x squared cancels out with the minus 3x squared, and the minus h cancels out with the plus h. Notice once again, every term on top ends up having the letter h in it. And so this limit is equal to the limit as h goes to 0 of 6x plus 3h. As h goes to 0, we can just plug in an 0 into my h, and we get 6x. So the derivative of g is simply 6x. So the derivative of g is 6x. And that allows me to say, well, if I want to find the derivative at a value, let's say 3, I can do that. I can say, well, 18 is that derivative. If I want to find the derivative at a value of -2, I can just plug in -2 and say, well, -12 is the derivative when x is -2. If I want to find the instantaneous rate of change when x is 5, I can simply plug in the number 5 into my derivative function and see that the instantaneous rate of change is 30 when the x value is 5. So that's how we can utilize an arbitrary derivative of, find an arbitrary derivative of g at x.